like activity with the consumer and producer surplus, so we're just going to work on that again. So remember that. We have consumer surplus and producer surplus. So consumer surplus, consumers buy stuff and people who buy stuff demand. So we're going to integrate the demand function and then subtract the area in between the demand function and the x-axis and then the equilibrium point. And then the producers, they make stuff, and so therefore they supply things. So you're going to integrate the supply function and subtract that from the equilibrium point area. Okay, so we're going to practice finding equilibrium points and surpluses. So example 1. Let's say we have a demand function of 8 minus, or x minus 8 squared, and a supply function of x squared. So you're going to take these two and set them equal to each other, because that's how you find where things are equal. Okay, so since both sides are squared, you could just square root both sides. If one side is squared and one's not, then you would want to expand this. So you'd expand it like this. Okay, but if you want, you can also just square root both sides because both sides are perfect squares. So if you expand, these two would cancel, and then you would solve the rest by adding 16x and then dividing, and you should get 4. So 4 is representing the quantity, and then you would have to plug it back in to find the price of the equilibrium point. So you're going to plug this back in either to the demand function or the supply function. It should be the same. If it's not the same, you did it wrong. So if you plug in 4 here, you get 16. If you plug in 4 here, you get 16. So that's the price. We'll probably just assume that all of these are in dollars. The notation that the book uses is like X with a little subscript E, and then I think it's like a P, the subscript E. I'm just letting you know in case you see it. I don't really care.
I can use whatever I want.
I suppose. I mean, I don't know. I would use the P for price. Otherwise, it doesn't really make sense. So,
I just make it Y.
But it's not really a Y, though. Because it's D and S. It's like demand and supply.
Well, you're right.
Anywho.
Do you use that for practice?
So you could write that as a point like this, and that's our equilibrium point. Use what for practice? No. I'm bringing that back to Windermere.
Wait, why is it Windermere's?
I don't know.
You stole Windermere's?
No, Miss Benefield borrowed it. She wants me to return it. Anywho, so after you find the equilibrium point, to find the consumer and producer surplus at that point, then you start plugging stuff in. So, to find consumer surplus, you're going to integrate the demand curve. So this is the demand curve. My recommendation is to expand that, because if you don't, technically, in order to integrate it, you would need U substitution. So my recommendation is to expand it. And you're going to evaluate that from 0 to 4, the equilibrium quantity, so the x value. And then you're going to subtract 4 times 16. So the equilibrium quantity times the equilibrium price, because that's like how much money we would be like buying, I suppose. Yeah, spending. So we're going to integrate this and get 1/3 x cubed minus 8x squared plus 64x. Plug in 0, plug in 4, do math. And then subtract 64. Alright, so let's see what we get. So 1/3, 4 to the 3rd, minus 8 times 16, plus 64 times 4, and then all of that minus 0, because when you plug in 0, you can just get 0, and then add, or not add, subtract 64. So that's going to be approximately $85.33. So that's your consumer surplus. Okay. So just remember, consumer's demand, so you're going to integrate the demand curve. Producer's supply, so you're going to integrate the supply curve. So producer surplus.
But now it's the 64 minus the.
Exactly. So it's kind of like the same thing, but just backwards.
And the 64 is like the QP.
QP, yep. So 64, or QP, minus the integral of the supply curve from 0 to Q. So we have 64 minus 1/3 x cubed from 0 to 4. So that's 64 minus, what's that, 64 thirds? Is that what 4 cubed? Yeah, 64 thirds. So let's see what that is. And I get approximately $42.67. So that, yeah, I guess I could have done that in my head. So that would be your producer surplus. These two amounts do not have to be the same. They don't even technically need to exist, but I think that they typically do exist. So one could be greater than the other. They could be equal, but I'd say typically they're not equal, but that's just like a coincidence. Like, they can be.
Like, so Missouri brings like extra money. It's like
Yeah,
extra
so
money that they both get.
yeah, producer surplus is like the added value they got from selling it at that price as opposed to, say, a lowered price. And then consumer surplus is like the added amount they perhaps saved buying it at that price and not another price.
It's the amount that, like, screw the customer with.
Sure, yeah. Okay, so that's consumer and producer surplus. And then we're just going to do a few examples of this. So
that's those numbers. Sorry to like mess up the video. But those numbers.
yeah. No, I paused it.
Oh, okay.
No, I didn't. I unpaused it.
Oh.
Wait,
Just
so
kidding.
it was-
So if one of the, so when you're solving for the equilibrium point, if one of the curves has a square root in it, then you would need to square both sides to solve. And when you square, since you're squaring a quantity, 7 minus x, you have to multiply two of those together, like expand 7 minus x squared. And then over here, when you square this, you have to square the 2, and you also square the square root of x plus 1. So the 2 squared is going to make 4, and then the root squared is going to get rid of the root. So on the left side, we'll get 49 minus 14x plus x squared. And then on the right, you're going to get 4x plus 4. Questions?
I sort of missed
Makes
what
sense.
you were saying.
So when you have like your supply curve, demand curve, if one of them is square rooted, you would have to square both sides to get rid of the square root. So when you square a binomial, that means to multiply it by itself. And when you square something like this, you have to multiply 2 times itself, and you also multiply this times itself. So that's going to give you 4 for 2 squared, and then x plus 1 for the square root of x plus 1 squared.
When you plug it back in.
Then you distribute here and FOIL here, and then solve. So to solve, you would, since this is quadratic, get everything over to one side. And then probably factor. So this factors to x minus, not 9, 6, no. What multiplies to 45? 15 and 3. There we go. Okay, and then when you set these equal to each other, you get 3 and 15. it's only going to make sense to have one of those as your equilibrium point. So they both might seem like they make sense, but only one of them is going to make sense when you plug it back in to find the price. So if you plug in 15 and 3 here, they both are fine. But if you plug them into the demand curve, 7 minus 15 is negative $8. So it doesn't make sense for an equilibrium price to be negative $8. They're not going to pay the consumer $8. That's not where they're going to meet up and agree on a price. So some of the demand or supply functions have like a domain. All of the domains are like x is greater than 0 or greater than or equal to 0 because you can't buy negative things. And so because of that, they also have like usually like a stopping point where the demand curve starts becoming negative and dips like below. So that's here. Like once you hit 7, the demand curve drops below the x-axis and no longer becomes usable. So ignore the 15 because it doesn't make sense. Keep the 3. So that's our equilibrium quantity, and then you would plug it back in here or here to get the equilibrium price. So if you ever get 2 solutions, plug them back in, and if you get a negative price, just make note that that doesn't make sense. Usually the book, or sometimes the book tells you like the domain, so it does tell you that for this on your homework question. There's one similar. It says x has to be in between 0 and 7. So there's one like that on your homework too, like x has to be between blank and blank, and then you can just ignore this because it's not between 0 and 7. Okie dokie. All right. Then you plug them in and find producer and consumer surplus.